Welcome back to Chapter 10. In this video, we are going to work to understand what areas of the brain are important for the different types of long-term memory we've been talking about. Now, this should allow you to be able to explain what would happen to these different types of memory if your hippocampus was removed. And we're going to do this using HM as an example. In the module, you will have an assignment that asks you to do this, or asks you to think about this. So we mentioned HM in a previous video, but let's go ahead and remind ourselves of who patient HM was. So HM, or Henry Molaison, was an individual who as a child had a bicycle accident and as a result had these uncontrollable seizures. So in his 20s, they decided that they would remove the medial temporal lobe or the hippocampus to try and stop those seizures because that's where the activity seemed to be limited to. Remember though, this is back in the 50s. We knew very little about memory. Hebb had just distinguished between short-term and long-term memory. We didn't know the hippocampus was so important in memory. In fact, it was HM that helped us understand the importance of the hippocampus in memory. So the doctor removed his hippocampus to prevent these seizures, and when he came out of the surgery and woke up, he no longer could remember new things. So he had impaired storage of new long-term memories. Doctor would walk in the room, tell him how the surgery went. Okay, great. He'd walk out of the room, come back. HM would again ask how the surgery went. We've seen this in TV shows and movies. We see this all the time, right? So basically what was happening is he couldn't form these new long-term memories, suggesting that the consolidation process or the encoding was no longer intact. Now his short-term memory and working memory seemed to be intact. He could remember some things leading up to the surgery, except for the few years right before were blurry, and we'll talk about that distinction temporarily. But so the biggest problem he had was forming new memories. So what type of amnesia is this? Anterograde amnesia. So again, this is just showing you here's a normal brain and here's HM's brain with the hippocampus removed. So now we can say HM had anterograde amnesia, but was this the case for all types of memory? So this understanding that HM had anterograde amnesia suggested the hippocampus was vital for the formation of new long-term memories. Now the question is it all three types of long-term memories we've talked about, procedural, semantic, and episodic? Back in the 50s, they thought it was. Now, as you'll see as we go through, HM and other hippocampal amnesiacs helped us to understand that it isn't all three types. The hippocampus isn't important for the formation of all three types of long-term memory. It is, though, specifically important for episodic memories. And this is important because you will need to know this for an assignment within the module. So the specific type of long-term memory we'll discuss more in a minute, although I already gave you a hint that it is episodic memory. Again, just showing you the hippocampus, and we'll see on the next slide or two that this is again in the medial temporal lobe. So now what about older memories? What about memories from his past? Now, studies have suggested time and time again that he had a slightly blurry memory for events that happened just a few years leading up to his surgery. So what type of amnesia would this be? Blurry memory for memories of the past. Retrograde amnesia. Now I have this starred with an asterisk because it's important to note here that the early reports did say that he could remember events from much farther back. So going back past 3 or 4 years, he could remember his childhood. He knew who his parents were. He knew who his childhood friends were. If he knew how to ride a bike when he was since he did know how to ride a bike when he was a kid, he still knew how to ride a bike. He remembered things he learned from school. So his memory from the past was there. And now if you were to look on to Google this or use AI to kind of summarize it for you, they're probably going to get it wrong because there's a lot of information out there. And I've done a lot of work sifting through it all. And here's where it gets complicated, is that first reports when he came out of surgery and they started doing all these memory exams on him was that he could not form new memories. But he could remember things from the past, although the stuff right before the surgery was kind of blurry and very fuzzy. And we'll talk about why that is momentarily, but that's a very important distinction to make. As he got older, as what happens when we age, is sometimes your memories for things in the past aren't as clear and you forget them, right? So when they tested his memory 10, 20, 30 years in the future, Some reports would say that he couldn't remember things from his past, but that wasn't an accurate report of what happened right after the surgery, of what happened when his hippocampus was removed. So that's important to remember. So summary, he had a slightly blurry memory for events that happened a few years leading up. He could remember things from his childhood, even older than his childhood, really. He couldn't form new memories of things he had experienced. So what types of long-term memories are these that we're talking about right now? Are they procedural, semantic, or episodic? These seem to be really personal experiences, right? Episodic memories. So his episodic memory was what was damaged. He had severe episodic memory impairments. Now again, let's distinguish between anterograde and retrograde. Think about anterograde, we said it was complete, right? He couldn't form any new memories at all for episodic memories. But he only had a partial retrograde amnesia. So he could remember things from earlier in his childhood, just not necessarily the few years right before the surgery. So again, suggesting that the hippocampus is very important in episodic memories, particularly the formation of new episodic memories. So again, let's remind ourselves that it's the medial temporal lobe that the hippocampus is located in. And this is important. It's the middle part of the temporal lobe. There's other parts, right? There's going to be an anterior, a posterior, inferior, superior, all these terms we talked about back in the anatomy chapter. Let's also remind ourselves of this model that we looked at previously, all right, where information comes in within our short-term memory while we're rehearsing and holding on to that information. The hippocampus is actively processing it. That's going to be the hippocampus. Then we consolidate that, we encode it, we get it into long-term memory. This is what HM was having problems doing, is getting things from short-term memory into long-term memory, right? Specifically for those episodic memories. Now, we also added on this, which you might not have gotten this information in Psych 100, but we also know that very long-term memories are stored in the cortex. In particular, probably the prefrontal cortex. Now, we don't exactly know all the ins and outs, and maybe some researcher thinks they do. From what I can gather is there's two models. One is that the information in the hippocampus is at the same time encoded in the cortex. It just takes longer for the cortex to actually consolidate and store those for a long-term period of time, so that when you're doing something, when you're actively having an experience, both the hippocampus and the cortex kind of get that information and start to store the information. The hippocampus just consolidates it faster. Another model that I've read about too is that this information from the hippocampus somehow moves over to the cortex over time. So again, remember, HM could remember things from a very long time back, right? So those older memories had gotten to the cortex. Things from his childhood, things from 5-6 years before the surgery, they had gone into his cortex. The cortex wasn't removed. It was the hippocampus. So getting that information from short-term memory into long-term memory, those few years leading up, kind of fuzzy, because maybe the cortex had started to process them, but hadn't processed it completely. We'll also talk a little bit later about the difference between memory storage and the types of memories we have, even if they're episodic, in the hippocampus versus the cortex. Again, the cortex is the important part here, right? It's separate from the medial temporal lobe. It wasn't. Now let's talk about semantic memories. So we've talked about the episodic. We know he couldn't form any new episodic memories. He had complete anterograde amnesia for those episodic memories. And he only had partial retrograde amnesia, right? He could remember things from his past because of that cortex storage. Now, semantic memories, what could he retain? Any previously learned old semantic material, things going back retrograde, right, were mostly intact. If he learned something in school, he could pretty much remember it, right? A lot of times you'll read that he couldn't remember form any new semantic memories. And that is true for the most part, but him and HM and other hippocampal amnesiacs seem to be able to remember very simple semantic memories and then recall them if given a cue. So for example, let's read this little excerpt from one of his interviews. So Dr. Milner asks, is asking, do you know who this guy is? So JFK, obviously, hopefully you understand or know who this is. He was assassinated and it was after HM's surgery. So if he couldn't form any new memories, he shouldn't know who JFK is. So Dr. Milner says his initials were JFK. HM says Kennedy. So from JFK, he can get the name Kennedy, right? Knowing that that's an important person. So Dr. Milner asked, what was his first name? John. Pretty impressive for a guy who can't form new semantic memory, supposedly, right? So this is just one example. I have a longer excerpt that I read in class. Now, are these types of memories implicit or explicit? Semantic and episodic. Explicit. So now what does this suggest about the role of the hippocampus in semantic memory? Now, while it's still debated, research suggests that the semantic memories are stored in the anterior temporal lobe. So remember we said the hippocampus is in the medial temporal lobe. So here's that hippocampus in the medial part. And then up here in the anterior temporal lobe would be where you're storing those semantic memories. And possibly that's why HM could form new semantic memories if given a cue. Now let's talk about his procedural memories. So his procedural memories completely intact. Okay, remember procedural memories are those memories for actions or skills. This suggests that procedural memories are not dependent on the hippocampus at all. And in fact, we'll talk later on in the movement chapter about the role of the caudate, putamen, globus pallidus, and substantia nigra, in other words, the basal ganglia, in the role of these procedural memories. And one example just showing that procedural memories were attacked in HM as well as other hippocampal amnesiacs is this mirror drawing task. So they ask the individual to draw a star just looking in the mirror. And if you don't believe it's complicated, try it at home. And if you can see here, this is the number of errors made on day 1. So this is the number of errors here, and this is the number of trials. So on day 1, lots of errors made, but over time you improve because you're learning a new skill. You're learning how to draw a star in a mirror. Well, if this procedural memory wasn't remembered at all, in day 2 you should go back to making the same number of errors. But you can see here significantly fewer errors were made. And again, they continue to improve. Now on day 3, you can see again, if there was no memory of this skill or task, they would make at least a lot more errors than this, but very few errors are made. And so again, though, each day this hippocampal amnesiac is coming back to learn the task, they're saying, oh, okay, I'll try it. I've never done this before. They don't remember actually having learned anything, but it's clear that learning has occurred. And so again, it's an implicit memory. Once they've learned the skill, it's automatic, right? So procedural memories, new procedural memories could be learned. Things they learned in the past, still intact. So now are procedural memories explicit or implicit? Just said it a few seconds ago. Implicit. So all of this suggests that procedural memories do not depend on the hippocampus. They depend on the basal ganglia. So it's a memory of how to do something, and it's slowly learned, but it eventually becomes a habit. Now, yes, a lot of these are going to be memories that involve movement, right? And so other areas of the brain might be involved, like the motor cortex or the cerebellum, but it's the basal ganglia that's important in initiating these movements. And so again, the storage of those procedural memories. So again, you look on the internet, you read a different textbook, it may mention the role of the cerebellum. Cerebellum's going to get a copy of that information, and the cerebellum is important in coordinating that movement, right? But the actual ability to initiate the movement depends on the basal ganglia. And as we'll talk in the movement chapter, people with Parkinson's disease have impairments of the basal ganglia and then thus impairments in initiating these procedural memories. So to summarize, did HM have more impairments in implicit or explicit memories? Explicit, severe episodic memories, especially new episodic memories, not so much semantic. Implicit memories were basically intact. We haven't really talked about short-term memory or working memory, but was it impaired? If you watched some of the other videos in the module already, you might have heard that no, it remained intact. So one of the kind of amazing things that they learned along the way was that they could give HM a string of letters and numbers to try to memorize. And if they left the room and he kept repeating those over and over again, he would remember them until his attention was turned away. So he could actively keep processing that information. He just couldn't encode it. He couldn't get it into his long-term memory. So based on all this, the function of the hippocampus suggests that it is critical for declarative memory, especially episodic memory, right? We also know that it's important in spatial memory. There are actually placed cells within the hippocampus that will fire action potentials when an animal, and even a human, gets into a particular location in space. And they've seen this by having animals run mazes and things, and so on and so forth. We also know that it's important for contextual learning and binding. And so without going into all the ins and outs of this, I just want you to think about your memory. So when you think of something that happened last week or last summer, it probably got a lot of details. You can probably remember what you wore, how you were feeling, what other people wore, right? But if you go back farther, 4, 5, 6, 10 years from today, and you think about memories that you have, it's more of a gist, right? So the hippocampus helps with context, whereas those older memories are stored in the cortex. They have more of a gist to them. So now you should be able to complete that assignment in the module. Of course, if you have any questions, join me in office hours.